Welcome to another tutorial on MATLAB. In this particular series, we are looking into the concept of Simulink and how to use Simulink in actual fields. Along with that, in this particular video, we will be discussing on how solver works in Simulink environment, how sample time is being adjusted based on different solver settings. So let's get started. So if you see on the screen, we can see there are multiple stages through which the solver work for adjusting the sample time. So basically, sample time is the time at which individual measurements are being taken. And if we make it very frequent, our calculation cost will be more. If we calculate it at longer interval of time, then it will be less costly. Basically, when we are sampling something, then we are measuring and then we are updating some values in the blocks in which like blocks that are being used in our model. So coming to how the solver works based on the sample time adjustment. If we see, there are four major steps that you need to follow, and that is being implicitly being calculated with the help of Simulink. And with the help of that, you will be able to get like how the things works on the back end. So let's discuss on the same. So the first step is estimation of the error. So basically, whatever the error that we are getting in the current simulation time, we need to estimate that error, like what is the actual error that can be estimated with the help of the orders of the differentiation that we have. So suppose if you consider a ODE 45 as your solver, then in that case your higher order will be 5 and your lower order will be 4. So in this case you will get the difference between the fourth order differentiation and the fifth order differentiation, and then you will be estimating an error. So once you do estimate of the error, then the next step comes whether the error that you have is within the desirable limit or not. So in Simulink, you will have the choice of defining absolute error and a relative error. So this is the formula to define the error criterion. So if you see here, that is being calculated based on the absolute and relative error that you are getting. And this will set a benchmark or a threshold, which will define whether you will be doing update or not in the sample time. So this stage is called basically error control. So here you will be telling like whether the error is enough or the error is very high or it is very low. So with the comparison of the estimated error, so in the previous step we have decided like what is the estimated error, and in the next step we already have the error criterion. So if the error criterion is less than the estimated error, so it's in sense like your estimated error is bigger compared to your error criterion, then in that case you will be needing an adjustment of sample time. Here the decision is being taken that we need an adjustment of the sample time based on our current simulation. So once this is being decided, let's we will be jumping into stage 3. So here this will be stage 3, and here we will be estimating like what should be our next sample time. To define that, you need to have a formula which is here. H new is the new sample time which you need to calculate, and H old is the old sample time. So whatever the sample time that was existing that we need to take, then we need to keep in the numerator the tolerance. So tolerance is the error criterion that we have, and the estimated error, so which is this part, so error estimate which we have. With this, if we get the 1 by the power of the order of differentiation that we are using in this particular step, that will be giving us the new sample time. So here we calculated how much is the sample time which we are expecting based on whatever the error criterion or the estimation that we are having. Then in the fourth step, what we will be doing, we will be re-evaluating our new sample time with respect to the old sample time. We will again check whether this condition is getting satisfied or not. If this condition is getting satisfied, then again we need to do the calculation for the new sample time. But if it is not satisfied, then at that moment we will be not needing any adjustment in the sample time. So at that moment, this particular sample time which we calculated will be proceeded to the next step, like next simulation or sample time. So suppose at time t you got your sample time, and whatever the next sample time that you are calculating, like h new, it is satisfying the criteria, then it will be proceeded to the t plus 1 second. And this is how the timing or sample time is being adjusted. So that is how we can also see, like on the back end, Simulink adjust the sample time. So basically this question always comes, like why there is an adjustment of sample time and how it happens. So this is how it works. And the adjustment of sample time is needed to efficiently solve the problem. So suppose if you have a model, then you want to efficiently simulate it, and that needs to be done with the help of adjustment of sample time, because if you are increasing your sample time, then you are making less calculation and making the simulation faster. If you are using very small sample times, then in that case you will be doing a lot calculation for the same simulation time. So this gives you an advantage, and this is only possible in case of variable type solver. And we will also see what are the other variable type solvers are present in the future tutorial, and we will see like how to use and where to use them in a defined way. So this is all about this tutorial. And yeah, in case you are liking the channel, please consider subscribing. In case you have any comment or query, please let us know in the comment section. We will be more than happy to clarify your doubts. Happy learning MATLAB. Stay connected. Thank you.